We've hit the immune system chapters and how our immune system actually deals with these pathogens. So the first part is on the non-specific or the innate immune system. So this is going to be very non-specific. So this is the first defense. It is also going to be very generalized and it's going to be immediate. It doesn't really matter what the pathogen is, whether we're talking about bacterial, parasitic, or viral. What will be coming up will be our specific or adapted defenses. And this is when we're going to be talking about antigens and antibodies. So it's going to be very specific. It's going to be very targeted. In this chapter, we're really talking about nonspecific defenses. They're immediate and they're going to be general. So many of these you're going to be familiar with, and we've already been discussing these. So first off, our physical barriers. So our skin and mucous membranes, these are going to be the first defenses. As I mentioned before, mucous membranes, because they're going to line the orifices to the outside world, this is really going to be the easiest way for things to enter. Our skin is our fortress, and if it's breached, if we get a cut, that's going to be an easy entry point. We also have chemical barriers. So, for example, the very low pH of our stomach. Not a lot of things can actually live in that environment. We also have some antimicrobial activity in our body fluids. So we have lysozyme in our tears and in our saliva that helps to combat bacteria. We have defensins that are basically like a natural Purell that helps to prevent bacteria from moving in. A big part of this first part of this chapter are going to be cellular defenses. These are going to be phagocytes. If you remember learning about general biology, we talk about phagocytosis, which is cell eating. So these are going to be immune cells, white blood cells, which are going to gobble up microbes. So we're going to be talking about the different types of phagocytes that our immune system has and then how they actually work. Some other defenses that we'll be talking about, inflammation. So even if you get a little paper cut, you are going to notice the signs of inflammation. It's going to turn red. There's going to be swelling. There's also going to be heat and pain, obviously, associated with it. And why is it those little paper cuts are always so painful? So this is actually a sign that our body is working to eliminate any pathogens. Now, if we have chronic inflammation and it continues, this can actually cause tissue damage. So I mentioned it's not summer in my house unless somebody gets cellulitis. And I've told you that my husband has actually ended up in the hospital for cellulitis, having to get IVs of very strong antibiotics. And the first time he ended up in the hospital, he actually had discoloration from the cellulitis. So his leg is permanently like a purple red color. And his doctor said he basically got a tattoo from the inside out. So it was because of that tissue damage that he actually has that discolorization. Now, something like that is going to be really severe, but if you get a cut, we do get inflammation, and that's a sign that our immune system is actually working. Another thing that can tell us that our immune system is working is fever. So fever is when our internal temperature elevates. So there's a few different reasons why we would want fever. So it's going to help to kill microbes, inactivate temperature sensitive toxins. Some people say that if you happen to get a fever with a vaccination, that's actually a really good sign because your body is taking it seriously. We'll talk a little bit more about that with vaccinations. Just because you don't get a fever doesn't necessarily mean that your body is taking it seriously, But some people do say that, it's not a bad sign to get a fever with a vaccination because your body is taking it seriously. The last thing that we will talk about that I think is a little more abstract and harder to relate to are molecular defenses. So we're going to be talking about complement, and we'll first see complement in the non-specific defenses or the innate immune system, but we will also see that in the specific or the acquired immune system as well. Now, I know that we will be kind of talking about these parts or these arms of the immune system separately, but don't forget that this is a whole body system. So our entire body is working together to keep us safe. So we are going to see some of these things that we talk about with the non-specific defenses in the specific defenses as well. The last thing that we'll talk about are interferons. I said that interferons interfere with viral infections. So we'll talk a little bit about how they work. All right, so a little bit more on our physical barriers. So obviously, mucous membranes, our skin, they're going to be that physical fortress, which is going to keep those infectious agents out. We also know that there are chemicals as well. So the pH of our stomach acid is very low. Not a lot can live in there. We also know that there are enzymes in our saliva and tears that help to break down pathogens as well. Now, if our skin actually becomes vulnerable through abrasions, cuts. I know in the wintertime when my hands get cold, they start to crack. That's going to be an easy entry point for things to get in. Insect, animal bites, burns. I talked a lot about cellulitis, and my cellulitis could have easily been from an insect bite, or it could have been from maybe a microabrasion in the skin. Our mucous membranes are going to cover all of those orifices that are open to the outside world. So that really is the easiest entry point for pathogens to move in. If you ever notice when you get ill that you've got that constant cough and sneezing, or maybe if you've got a GI virus or something going on, you've got diarrhea, vomiting, constant urination, that's basically your body's way of trying to flush itself of these pathogens. So it's kind of like the body saying, get out now. So those are our physical barriers. Now, getting into those cellular defenses, why is it that we need those cellular defenses? Well, if things happen to get in through our mucous membranes or through cuts in our skin, now those pathogens are going to start to travel. So that means that we're going to need these phagocytes, these immune cells, to gobble up these pathogens before they start causing harm. So if you've taken AMP2, you've probably talked a lot about blood and a lot of the portions of the blood. So our blood is mostly plasma, which is really the fluid portion, and then we have formed elements. So we have red blood cells or erythrocytes, which carry oxygen. We also have platelets for blood clotting, and then we have white blood cells. And if you've taken AMP2, you've probably seen these things up close and personal underneath the microscope. So we're going to be talking about some of these different white blood cells. And we can actually categorize these white blood cells into two different categories. So there's granulocytes. If we were to stain them, they show granules and they have lobed nuclei. Agranulocytes don't show granules when stained, and they have round nuclei. So the cells that would fall under granulocytes would be basophils, mast cells, eosinophils, and neutrophils. Basophils and mast cells, they will release histamine. And histamine is kind of like a flare gun going off, and we're going to be seeing that in inflammation. And later on, when we talk about what happens when our immune system kind of goes awry, we'll be talking about allergy and histamine's effect on allergy. We'll also talk a little bit about eosinophils. So eosinophils we sometimes see with allergies, and we would see eosinophils, their numbers rise if we had a helminth infection, so a worm infection. So we'll talk a little bit about what they do. Neutrophils, these are kind of the guard cells, and these are the most numerous. So neutrophils begins with an N, numerous begins with N. These are going to be in high numbers because they're going to stand guard. And if a pathogen goes by, they're going to reach out, grab it, gobble it up, but then they're going to poof, they're going to die. So that's why we need these in really large numbers. Agranulocytes, we'll be talking about one in this chapter, but we'll be talking about lymphocytes in the next chapter. Lymphocytes are B and T cells, and this has to do with our specific defenses. So a little bit more to come on them later on. Monocytes will actually circulate in the blood, and then they'll get into tissues, and they'll power up into these big macrophages. So first, we're going to see macrophages in this chapter because they will gobble up pathogens, but we're also going to be seeing macrophages in the specific immune system because once they gobble up a pathogen, they can actually display the pathogen proteins on its cell surface, almost like a storefront display window. So if you go window shopping and you're looking in the window to see what the store has, to see if maybe you want to go in to buy something, that's what they put in the display to kind of entice you to get into the store. Macrophages will put the pathogen's proteins on its cell surface so that other cells in the body can actually see that, okay, this cell has come in contact with a pathogen. Now we need to take this seriously and mount an immune response. So first we're going to see macrophages gobbling up these pathogens in this chapter. Next chapter, we're going to see the macrophages involved in the specific immune system. So again, if you've taken AMP2, you've probably seen a chart like this, and this is just really the development or the stem line of the blood cells, just so that you can see all of these different granulocytes, agranulocytes. I'm not going to hold you to knowing this, but just a little background of where these cells are actually coming from. So a little bit more on these phagocytes. So these cells are going to circulate through the body and they're going to gobble up these pathogens. So the first one that, let's say that a pathogen enters into our body, more than likely or hopefully the first phagocyte that they're going to encounter are the neutrophils. So remember, neutrophils are in huge numbers. They can only live for a couple of days. And what they will do is that when they encounter a pathogen, they're going to reach out, grab it, gobble it up, and then they're going to die. If you've ever had a cut where you end up with pus that forms, a lot of times that pus is not only the dead pathogens, but then also the neutrophils that are basically piling up in those high numbers. So these neutrophils are going to stand guard in high numbers, and hopefully they will gobble up these phagocytes before they can start to get into our body. Now, I've already talked about those monocytes. They're going to circulate in blood, and then they can invade tissues. Once they get into the tissues, they're going to power up into these big macrophages. These macrophages can gobble up the pathogens, display them on their cell surface, and they're actually going to help in long-term immunity because they can actually present to the cells in the specific immune system. So we're going to be seeing them a little later on. All right, so how does phagocytosis happen? So phagocytosis is cell eating, and I did post a little video so that you could see these white blood cells gobbling up these bacteria. The first thing that happens is that these white blood cells, they have to find the foreign agent. Then they have to bind to the foreign agent. Then they need to ingest it. And then once it's inside, they've got to tear it apart. That's going to be digest. So there's 4 pieces of phagocytosis: find, bind, ingest, and digest. So we're going to examine each of these a little more closely. All right, so how do we know that something is wrong? How is it that these phagocytes are going to be able to find these pathogens? Well, these infectious agents can actually release substances as well as infected tissues. They will release substances. Some of those granulocytes will release histamine. Histamine is like a flare gun going off, so that all of these white blood cells see this flare gun and they're like, whoa, something is happening. Let's move into this area. Now, those phagocytes already at the scene, they're going to be releasing cytokines. And if you remember, cytokines, those are immune chemicals that are going to communicate with the rest of the immune system. So this is actually how the immune cells talk to each other. So these phagocytes see all of these flare guns, all of these chemicals in the area, and they are going to start to move into the face of danger. These guys are going to be running into the face of danger. If you remember, we talked about bacteria either going towards something good like a nutrient or backing away from something hazardous. The mechanism that they use for that is chemotaxis. Phagocytes are going to be doing the same thing. They're going to have receptors that are going to pick up these chemicals, and then they are going to bind to these chemicals, and they're going to move towards it by way of chemotaxis. So this is going to be the finding. Flare guns going off, phagocytes moving into the face of danger. All right, so now they've got to bind. They've got to adhere to these foreign agents. So just like the bacteria, if you remember, I talked about the virulence factors. If a bacteria can stick to a cell, it's going to be more dangerous. A phagocyte has to be able to latch onto this phagocyte, or this pathogen rather, in order to phagocytize it. So it's got to stick to it. Here's the thing, these bacteria can be kind of sneaky, so they can actually have those thick slime capsules that stop those phagocytes from binding to it. So if that phagocyte tries to attach to it, kind of slides off of it like that pathogen is too slimy to actually stick to. Well, here's the thing. Fortunately, our immune system has a way of fighting back, and they can actually coat that bacterial cell with antibodies or complement. So I know that I mentioned cytokines as being one of those words that we should remember with the immune system. Opsonizing is also another term. So opsonization means that we're going to coat something. So if the immune system coats that bacterial cell with complement and antibodies, then those phagocytes are going to be able to stick to it. So those phagocytes are going to have receptors for those things so that it can actually bind to that bacterial cell. Now, ingestion is probably the quickest part, where it's going to surround that pathogen with a fake foot that we call a pseudopodia, and then it's going to ingest that cell. It's going to take it in. Now, remember, we can't punch a hole through the cell because now that phagocyte is going to die. So it's going to surround that pathogen and then take it in through a vesicle where the membrane kind of forms around it. And now it can actually intake it. It can ingest it. Again, that video that I posted does a really good job of showing that finding, binding, and ingesting. All right, now once that phagocyte has taken in that pathogen, now it needs to get rid of it. This is where digestion comes in. So I often talk about in cell biology, the lysosome being the garbage disposal of the cell. This is where that pathogen is going to be sent. It's going to be sent to the garbage disposal. That lysosome has digestive enzymes that are going to break down that microbe and tear it up so that it can either use its parts or get rid of those parts as waste. Now, there can also be other ways to get rid of it, things like hydrogen peroxide, reactive oxygen, like nitric oxide, and these things are going to damage those microbial membranes. If you remember, we talked about those virulence factors, and remember that virulence factor catalase. That means that if an organism has that enzyme, it can actually break down these reactive oxygen species. So remember, some of these microbes can be pretty tricky, and they can try to evade this killing. So remember, these bacteria can be really sneaky. So some of these bacteria can contain capsules. So some of those capsules can be slime capsules, so those phagocytes can't bind to it. If you remember way back in the beginning of chapter 1, we talked about the bubonic plague and the causative agent, Yersinia pestis. What made this particularly nasty was that it contained a capsule, and capsules are going to protect it, so they are not easily digestible. So it's going to be really kind of tough to get rid of an organism like that. Some bacteria can actually block that phagolysosomal fusion, so that vesicle fusing with the lysosome, where they can actually grow and divide in there. So something like Mycobacterium can do that. Some, as we know, as we talked about with virulence factors, can release toxins that kill phagocytes. So staph can release leukocidin that outright destroys white blood cells. Strep can release streptolysin that stops those white blood cells from engulfing the bacteria. So those bacteria can be pretty sneaky in evading our host defenses. Now, there may be some larger things that our body needs to get rid of, like those helminths. If you remember, we talked about worms in the parasitology chapter. Eosinophils are going to help us with that. These worms are going to be too big for those phagocytes to gobble up. So what eosinophils can do is that they can release MBP, major basic protein, that basically blows holes in the side of the worm body and chops them up into little pieces so that those phagocytes can come in and then they can gobble up those little pieces. There are also natural killer cells. I call natural killer cells the ninjas. They will recognize specific proteins on the surface of virally infected cells and also cancer cells, because cancer cells can look kind of wonky. And what they will do is that they'll secrete perforin, which blows these little tiny holes, perforates that cell, and give it the kiss of death with granzyme, which causes apoptosis, that programmed cell death, and basically takes out that cell. So we have cancer cells that kind of happen in our body, and hopefully our immune system, especially these natural killer cells, are good to recognize those cancer cells so that they can actually get rid of them before they start that uncontrolled cell division. So I often call these natural killer cells the ninjas, because they're going to go around and they're going to take out these cells that have been infected and just don't look right, where there's something wrong with them. So that has to do with phagocytosis. Remember, these bacteria, they can be pretty sneaky, but our immune system does have ways of actually targeting them.